Hello friends, welcome to the class. Today we will solve the problems of inverse trigonometry exercise 2.1. Okay, so here the first question, find the principal value of sine inverse 1. Okay, principal values, we have to find the principal values. Okay, the first question is sine inverse minus 1 by 2, sine inverse negative 1 by 2. Okay, now we know that sine inverse negative 1 by 2 must be an angle theta, and this theta must exist or should belong to the range of sine inverse, that is from minus pi by 2 to pi by 2. Okay, this theta will be considering in radians. Okay, in radians. Now the theta must exist from minus pi by 2 to pi by 2, which is the range of sine inverse. That's the principal branch value. Okay, or principal value branch, whatever it is. Now when we look into the the ratio of the unit circle, you'd see that pi by 2, minus pi by 2 to pi by 2 is here. This is 0. So sine inverse, the range of sine inverse is this area. Okay, here is where sine inverse, the range of sine inverse exists. Okay, now here it's sine inverse minus negative 1 by 2. Now we know that sine 30 degree is equal to 1 by 2. Okay, now here in the first quadrant, if you see, sine is positive here in the first quadrant and it's negative here in the second quadrant. Okay, so the value of the sine will be positive here in the first quadrant. Okay, so we can write sine 1 by 2, sine inverse 1 by 2 is equal to 30 degree, which is equal to pi by 6, and this belongs to the first quadrant here because everything is positive here, sine is positive here. Okay, here because now if you look, this is the positive direction where everything goes positive. Okay, here it's all the values for sine is positive. It's 1 by 2, 1 by root 2, root 3 by 2, and 1, positive 1 here. Okay, the angles are also positive, pi by 6, pi by 4, pi by 3, and pi by 2. Now when we look here, it's in the negative direction. Here all the values will be negative. Sine is negative in the fourth quadrant, so it will be, all the values will be negative, like minus 1 by 2, minus 1 by root 2, minus root 3 by 2. Even the angles, since this is minus pi by 2, all the angles here will be negative. That is minus pi by 6, minus pi by 4, minus pi by 3, and minus pi by 2. Okay, and here in the question we have sine inverse minus 1 by 2, so it must be here in the fourth quadrant. Okay, so we can write this as sine inverse negative 1 by 2 is equal to 30 degrees. Okay, and that is negative pi by 6. The reason is, since minus pi by 6 belongs to the range minus pi by 2 to pi by 2, close interval, so it belongs to the range. It is inside the range. Okay, this is the range and it exists inside the range. Since minus pi by 6 belongs to the minus pi by 2, we can say that minus pi by 6 is the principal value of sine inverse minus 1 by 2. Okay, therefore minus pi by 6 is the principal value of sine inverse minus 1 by 2. Okay, that's it, simple. Now second question, cos inverse root 3 by 2. Now again we know that cos inverse root 3 by 2 must be some angle. Okay, where, and this angle must exist, this theta must exist in the range of cos inverse, that is 0 to pi. The range of cos is 0 to pi. Now when we see that in the unit circle, this is 0 and this is pi, and this is pi by 2, so this is the area where cos exists. And now when we see that cos inverse is positive value, cos inverse is a positive value, so cos is positive here, it must exist here. Cos is negative here, it doesn't exist here. Okay, this value is not here, this value is in the positive area, and that is within the range 0 to pi. Okay, now cos is root 3 by 2. Now where is cos root 3 by 2? It's at an angle 30 degree, which is pi by 6 again. Okay, so we can say that cos inverse root 3 by 2 is equal to pi by 6, since pi by 6 belongs to the range 0 to pi, close interval. Therefore pi by 6 is the principal value of cos inverse root 3 by 2. Simple. That's it. Okay, now the third question is cosecant inverse 2. Cosecant inverse 2. Again, cosecant inverse 2 must have an angle theta, and this theta must be in the range of cosecant inverse, the principal value range. Okay, the principal value branch. What is the range of cosecant inverse? Cosecant inverse, the range of cosecant theta belongs to, the theta must belongs to the range. What is the range? It must be minus pi by 2 to pi by 2, close interval, minus 0. Now when you look here in the unit circle, ratio of the unit circle, you'll see this is minus pi by 2, this is pi by 2, and this is 0, because 0 is not considered because cosec goes to infinity at 0. Okay, that's why it's minus 0 here. Now this is the area where cosec exists, not at 0. Okay, now cosec inverse 2. Now you know that cosec is positive here in the first quadrant, and it's negative here. Since this is a positive value, it must be here in the first quadrant. You know that cosecant how much? 30 degree. Cosecant 30 degree is equal to 2. Okay, so cosecant inverse 2 will be 30 degrees, that is pi by 6 again. Okay, so we can say that cosecant inverse is pi by 6, since, and again we have to try the reason, since cosecant inverse belongs to the range minus pi by 2 to pi by 2 minus 0. Okay, therefore sorry, this is not cosecant inverse, its range. What is the range? Pi by 6. Pi by 6 belongs to this range. Therefore pi by 6 is the principal value of cosecant inverse 2. Okay, that's it. Now fourth question is tan inverse negative root 3. Now again, tan inverse negative root 3 must be some angle at theta. Okay, and this theta must exist in the range of tan inverse, so the tan inverse should belong to the range. What is the range of tan? It's minus pi by 2 to pi by 2, open interval. It's open because at pi by 2 tan goes to infinity. Okay, now when you look here and again in the unit circle, this is minus pi by 2 and this is pi by 2. Tan belongs here. Okay, it will not go to pi by 2 because pi by 2 is infinity. Okay, this is 0. Now this is the area where tan must be here. Now you know that tan is positive in the first quadrant and it's negative in the fourth quadrant. So now since this is negative, it must be in the fourth quadrant. Okay, where it's moving the negative direction, and all the values will be negative. Okay, all the values will be negative here. So you know that tan 60 degree, tan 60 degree is equal to root 3, or you can say that tan inverse root 3 is equal to 60 degree, which is pi by 3 in radians. Okay, since this is a negative value, it will be here. So tan inverse negative value, negative root 3, is equal to negative pi by 3, because everything here is negative. It will be minus pi by 3 here. See, minus pi by 2, so it's minus pi by 3 here. So this is, and it belongs to the range. it is inside the range. Okay, so we can say that tan inverse root 3 minus root 3 is equal to minus pi by 3, since minus pi by 3 belongs to the range minus pi by 2 to pi by 2, open interval. Therefore minus pi by 3 is the principal value of tan inverse minus root 3. Okay,